Welcome to everybody. So today's virtual company showroom features Guardsquare. They were founded in 2014 and they've grown to the position of global market leader, providing mobile app security solutions to more than 800 customers worldwide. Our two representatives from Guardsquare today are Andre Jacobs, who's group leader for the LLVM team, and CERN alumnus James Hamilton, who's a software developer at Guardsquare. So you can find out more about them by checking out the event page on alumni.cern. Without further ado, we can get proceedings going. So thank you very much. I hand over the floor to you, James and Andre.
Okay, thanks. Let's, as you said, just get started. So what am I going to talk about today? What am I doing here? I want to talk about Guardsquare, of course, and I'm going to tell you a little bit more about what it is that we do, a little bit about on a high level, on a kind of business level, try to give you an impression of what it is that we do and why we do it. Then maybe more interesting, the technology part of it. How do we do it? What are the technologies involved? And what are some of the technical details of what we do? And then at the end, a little bit about who does it and why Guardsquare might be interesting for you to have a look at in case you're looking for a new opportunity in the future. This slide summarizes it very high level. A company about mobile security. We focus on protecting apps. And I'll get into more details about what that means, of course. But very briefly, the current state is that we are a growing company. I think that's very important and interesting to underline. We're not a very big corporation with thousands of employees, but we're also not anymore the small startup that we used to be. And so we're already quite established in that sense. In the end, when you develop code at Guardsquare, when you implement something, it ends up at one of our 800 customers, which is already quite a significant number. But those 800 customers, they have millions and billions of end users that use their applications, which will in the end be executing the code that we are developing. So what you're doing, it usually ends up in someone's pocket nearby, and probably your own pocket as well when you pull out your phone. We have 4 offices: Leuven, Boston, Canada, and in Germany. And we have at the moment 5 products, and I will go into detail of all of these, of course. So we have a lot of customers all over the world. We're quite an international company in that sense, not just because of our customers, but also the company itself. You saw the offices, but also in the Leuven and the German office, we speak English mainly. When in the office or in meetings, of course, English is the primary language. We have lots of nationalities in the office, and in general, it's a company that really tries to be very inclusive in that sense. Very briefly, the history of Guardsquare from a product perspective. So the way it started is in 2002. So that's not when the company was started, but that's where the story starts. So our founder, Eric Lafortune, he had an idea in mind. He was working on Java code, and he had this idea that, you know what, all of this JIT compilation stuff, I think I can make Java jars smaller and faster. The oracles of the world, they were like, no, JIT compilers, they are better. They're gonna be faster and whatever. Turns out Eric was right. He started on this hobby project in 2002, and it very quickly became very popular. And there was a lot of, he put it on, it was open source, he put it online, and there was a lot of traction, a lot of big companies using this, asking him like for support, essentially. You know how it goes with open source, lots of questions come your way. And at some point, also questions about security, because optimization, shrinking, and obfuscation, to some extent, they're very closely related. So that's when DexGuard was made, or the sort of more bigger brother of ProGuard that also introduced obfuscation on top of the shrinking and optimization that ProGuard already offered. As I said, customers were already actually coming in, and the company didn't even exist yet. So in 2014, it was a high time that Guardsquare was founded officially, and when the company was officially registered. In 2015, the first employee next to Eric was hired, and then in 2016, that employee started working on an iOS obfuscation tool, because DexGuard was for Android, and so the question came in for iGuard as well. So between that time, between 2016 and 2020, the company became more stable. From was still a startup, but still slowly growing into more of a scale up. When I joined in 2017, we were not a startup anymore. We were a scale up, about 20, 30 people. So you can already imagine from 2015 to 2017, it was a very successful couple of years. Growing from 1 employee to 30 employees is not a small feat. And as we went along, IXGuard also became more stable and was able to catch up a little bit with DexGuard. Of course, DexGuard is still more mature, but around 2019-20, we became market leader in terms of providing obfuscation for mobile applications. So that's when we started looking at broadening our horizon, building on top of our background. What we will be doing in the future will always be related to compiler and program analysis. But we were looking at, hey, what can we do more? How can we further look at mobile application protection from different perspectives? And so that's when ThreatCast and Upsweep were added in the following years. ThreatCast is our monitoring tool. So IXGuard and DexGuard, they will introduce security mechanisms for your app that at runtime, when the app is being executed, will report to ThreatCast when threats are detected. This allows customers to get some insight into what's happening with their application and to correlate this data with their own data, for example. And then AppSweep is our static analysis tool or mobile analysis tool to detect security flaws. At the moment, it's Android and static only, but it will be extended, of course, in the future. So that this is the broad picture of what we are doing at the moment. So we are a company that is providing as broadly as possible, and we will still extend and expand our product lines, of course, with mobile security tools in a very broad perspective, but very much focused on the developer's perspective. As you can see here on the slide, the software development lifecycle is being represented because that's our point of view. We are compiler guys. We make tools for other developers for them to be easy to use. So from their perspective, the developer user experience is very important for us. For them to integrate with these tools and then have in each step of their development cycle the additional reassurance that their apps are being protected or are at the very least secure. So this is a very brief overview. So ProGuard is optimization, it's open source, you can find it on GitHub. AppSweep is a free mobile application security testing tool. DexGuard and IXGuard are the more commercial obfuscation and protection tools, and then ThreatCast sort of hooks into DexGuard and IXGuard. So what does that mean in terms of technology? This was all very high level, a little bit on the business level. What does that translate into, technically speaking? So first I want to focus on the obfuscation part. It's still most of the R&D department is still working on this. The other products are a little bit newer, so that makes sense in that regard. And so I want to focus a little bit on where it all started, essentially. So DexGuard is for Android, and it uses ProGuard Core, which I will get to at the end, and it's written in Java. IXGuard, it's for iOS applications. Some of you may know that iOS applications, they translate into normal assembly. There's no VM underneath, and the compilation toolchain that is used is LLVM based. It's maintained by Apple for a large part. And so IXGuard is written in C++ because it uses LLVM. So I already mentioned we focus on the developer's interests. So what we don't do is, we're not a very typical, I guess, security company in that way, because if you think about security and maybe mobile security in this case, usually the articles, the headlines, the newspapers, or the news in general, they will talk about what security means for an end user. If we talk about privacy, for example, it's always about us as users, our privacy, our data being safely stored. If we talk about exploits, remote code execution on your phone, that sort of thing, that is always regarding end users who are using phones, who are using applications. And so the big players in that sense, the Apple and the Google of the world, they want to make sure that their environments, their operating systems, that they are very well secure to protect their users, their customers in the end, their security. This leaves a little bit of a gap for developers. If I'm a developer and I'm making an application, in the end, what that's happening is I'm sending it into the world, available for everyone. And at that point, there are less incentives for Apple and Google, and there's less guarantee from their point of view that my developer code will be protected as well. And so that's where we come in. We try to protect the developer's interest by protecting the application. So hardening and mitigating, so making sure that the application is more difficult to reverse engineer. That's in the end what we are all about protecting against reverse engineering. And with Threatcast and AppSweep, we try to make sure that developers can have this sense of security as soon as possible, instead of having to wait until the app is sent into the world and then just hoping and praying that there won't be any fallout later on when apps are getting cloned or features are being reverse engineered. Threatcast and AppSweep, they help to give a little bit more insight earlier on. So what we don't do is we don't build the kind of security that you are maybe imagining that entails strong cryptography, maybe authentication libraries, secure storage, that sort of thing. That's not what we do. What we focus on is protecting against reverse engineering, and I will explain in the following slide what that means. But maybe first a little bit about the developer interest. So why am I interested in security in that sense as a developer? Many reasons, but when it all boils down, what it all boils down to in the end is that these app developers, they are usually companies, of course. Sometimes the apps that they make is their core business. That's the only thing they do. It's just apps. Sometimes apps, they're not just being built for fun. They are part of a strategy in a bigger picture sense. So in the end, a lot of time and money is invested in building these applications, and there are indeed some if these applications are abused in some way, it will translate often in direct revenue loss. And that's what we have to be honest about, because if I'm developing an application and I depend on this app generating revenue through in-app purchases, through advertisements, through subscription models, whatever, if a reverse engineer is able to not pay for a feature and just use the feature as is, or remove advertisements, that sort of thing, then I just lose revenue. So these are some of the direct threats, including algorithms that I have in my application that I don't want to be reverse engineered. Indirectly, there is also like the brand reputation, the trust, feature leaks. You don't want to always show to everyone what the next thing is going to be. Also trust in a game, for example, cheating in theory, if someone's cheating, it's not gonna maybe directly make me lose money, but at least the rest of the user base is gonna be very unhappy, and I will just lose trust as a game developer. Like, this is not a fun game anymore. And that's why, as a developer, it's important to think about these things. So reverse engineering, what does that mean? That's in the end what most of us at Guardsquare are very much interested in, reverse engineering and this whole process. The model that we operate in is, we call it man at the end, MATE for short, because as I said, what you do as an application developer is you send your app into the world, and unlike, for example, in a typical web application, there is no intercepting traffic or messages. It's just the app is downloaded to a phone. You and I, we can all download all of these apps from the Play Store. We have our own phone, and we control everything. We control the hardware, we control the app at that point, and we basically have unlimited time and resources, because there is no easy way, there is no server traffic, or at least not always, that you can disconnect or that you can throttle in order to limit access to the app. So that's a very complex model to work in, because infinite time, infinite resources, that's already fairly difficult to deal with in security. On top of that, many of these reverse engineering attempts, they are human-based. Some security threats are automated, like if you're talking about API endpoint security, you're usually talking about protecting against scaled automated attacks. Of course, there's always a human component in security, but in this case, it's primarily human because there is a human who wants to achieve something. Again, cheat, not pay for something, steal intellectual property, steal ads or replace ads, that sort of thing. They will find the path of least resistance. You can really try to come up with all kinds of complex security schemes. In the end, if there is just an easy way to achieve the same thing, they will just take that way. Obviously, it makes sense. And so secondly, it makes it very difficult to formally model this kind of model, because unlike with an authentication scheme, for example, I suspect some of you or most of you have all seen the diagrams with Alice and Bob, and you can really formally mathematically verify the security of your authentication scheme. That's in this case extremely difficult because, again, there is this human component. They don't have to adhere to the specific code paths that are in place. Through various means, they can change the code execution completely. They can change the environment. They can do anything basically because they control everything. That's the model that we're working. So if it's so difficult, then how are we able to protect, or how are we able to do anything at all? The reason is that whatever you're trying to achieve, the reverse engineering process is often, well, not the same, but there is a structure to it. Many people, when I talk to them about obfuscation, about reverse engineering, they're like, yeah, okay, but for iOS, for example, an application is compiled to assembly. What can you do? It's assembly, it's bits and bytes. First of all, you would be surprised. So reverse engineers are very good at reading assembly. They're not scared of it at all. But secondly, they often don't need to read it at all. They will look for interesting locations. They will identify first what it is that they are trying to achieve. If you're looking to remove advertisements from an app because they annoy you, then you go look for a function that's maybe called fetch advertisements from server. You list all the function names and you start searching through them, finding things that are interesting to you. Often for many of these applications, that's possible because they are usually managed languages like Java, Kotlin, Objective-C, Swift, which means that there is a lot of metadata in the app to be able to support things like reflection, even inheritance, that sort of thing. This metadata basically it's just a list. It's just all the functions that are in your app, and you can just list them. And basically, you don't have the source code yet. The assembly might still be a bit difficult to decompile, but even that you can decompile into something that resembles C, and you have something that's very readable. And that's things you can do with decompilers. There's many tools that will help you to do this sort of thing. After you've identified interesting locations to start reverse engineering, you have to analyze them, of course. I can find this function, but then I have to understand what does it do. If I just remove this function, will the application completely break, for example? That's possible, that sort of thing. Can also be just that you're trying to achieve something more complex than just patching out one function. So you have to analyze the content of the function and how the function relates to everything else in the application before then you can do the last step, which is modifying the app. It's essentially the modification step. The last one can be static. As I said, you can just put some knobs in place and recompile or reassemble, resign, and you're done. Or you can do it at runtime with a debugger or with Frida, tools like Frida that allow you to change the behavior of an application at runtime. But modification is often the end goal. I have here static and dynamic at the bottom of the slide because all of this you can do either on your computer, just looking at the assembly, as I said, or at least with the help of some tools, or you can do it dynamically, executing the application on your phone and trying to, at runtime, understand what's going on. So finally, what does that mean for us? I've tried to explain the problem a little bit. What does that mean for us? It's a complex problem, so how do we solve it? We solve it like any problem. We're a bunch of engineers at Guardsquare who really like solving problems, and so we know how to solve them. We split up the problem. We look at all of the pieces individually, we put them together, and we build a comprehensive solution in that way. So I won't go into detail into this entire slide because that's going to take too long, I think. But essentially, we look at the environment. Where is the app being executed in the application itself? Because an IPA and an APK, essentially, they're zips, but they are completely different. So there are some interesting differences or interesting mechanisms that we have to understand and use to protect. And then, of course, the code itself, we have to have a very good understanding of what it looks like. What is the binary format on a GNU system, for example, on an iOS device? And so it's a macro format. We have to know it and understand it in order to protect it. Same for Java, of course. What's in those jars? What is in those ELF files? How are they executed? What does the dynamic linker do? And then what kind of mechanisms do iOS and Android have in place? So that's why it's a circle. It's all circular, of course. All of this, in order to protect this, we have to really have a deep understanding of the ecosystem. So often we are looking at open source code, the GNU kernel, the DYLD source code, the Android source code, that sort of thing, because we need to understand it in detail to be able to protect apps at runtime. On top of that, as I mentioned, there's also the static analysis. We have to make sure that whatever we put in there isn't just trivially understandable or removable statically as well. So we have to protect it with obfuscation mechanisms, which require a lot of knowledge about compilers, essentially, because we try to modify the structure of the code, but the semantics have to stay the same, of course. So we have to know what's possible, what's not possible, and then also try to interpret what it means from a reverse engineering perspective. And that's what we do with ProGuard core and LLVM. This is, for example, how IXGuard works on a very high level. We operate on the bitcode level, so apps need to have bitcode in them. We have our intermediate representation passes, so we work on the middle end of the compiler. We transform, we inject code, we do everything that we need to do to obfuscate the app. We recompile it at the end, and then this recompiled version is protected or more protected against reverse engineering, and that's the one that can be uploaded to the App Store, of course. So we operate in a post-processing mode, which means that we never see the source code of the app, for example. So very briefly, some of these protection mechanisms, what could they look like, or what could you imagine they look like? So this is one example of a static obfuscation technique where we apply reflection and encryption to make it more difficult for a reverse engineer to understand what's going on when they are looking at their decompiled version of the code. So on the left box, you see a simple function foo, and it calls a function bar, and it stores a result. It retrieves a string, basically. So as a reverse engineer, I might recognize foo like, hey, I'm trying to do something with that. That's interesting. What does it do? Okay, it calls a function bar, and off you go. You can probably understand what's going on. Like really, the decompiler from assembly can generate this kind of decompiled code. It's all there in assembly. The function call is visible. The function name is visible for some reason. That's all possible in most cases. So what we do is we at least rename the function foo to x. That's already helpful. Then if you're looking for foo, you're not going to find it. And then the function called bar, we can also, for example, apply reflection. And that's already a little bit more, you need a different tool to find reflection calls. And it's just a little bit more convoluted already. But then if we go one step further and we encrypt the function name bar, and we end up with the box on the right-hand side, you can imagine it's at least, it's never impossible. It's never impossible to understand what's going on because this code has to run, it has to work, it has to function in the end. But the bar is significantly higher. A reverse engineer, if he sees the right-hand side versus the left-hand side code, is going to have a much more difficult time understanding what's going on and trying to go through this identification step and even analyzing what's going on. Another example is control flow obfuscation. If I'm analyzing, if I'm looking at a function and I'm trying to understand what it does, of course, we're all programmers or reverse engineers. They definitely have a programming background. They know what the if conditions, what the else conditions, of course. And so it's very useful for them to see the structure of a function. If a parameter is passed into this function, how does it affect the code paths that can be taken? Okay, if else, if through this branch, if false the other branch, and you can create a control flow graph, like the example here, that just gives you an impression of what's going on. So what do? We take away all of the structure through flattening, linearization, you name it, and you get something that is semantically equivalent. For example, with flattening, you can imagine a control block, and it's a dispatching mechanism, in fact. It will be semantically the same, but it's completely linear or flattened. And as a reverse engineer, all of a sudden, there's no information anymore. At least it's much more difficult to retrieve. So those are two examples of static protection techniques. What about runtime? What am I talking about when I'm saying iOS, Android? You have to execute the app. What does it all mean? Essentially, crudely speaking, let's say everything is fair game for a reverse engineer. So you have your app. It has structure to it. You have a Mago or an ELF binary. There's headers in it. They define which dynamic libraries need to be loaded. There is a code section, there's a code signature, there's resources. All of these things, depending on what I'm trying to achieve, I might be interested in tampering with them. I might be interested in patching some code. I maybe want to replace the signature with my own signature so that I can re-upload it to a third-party store. I want to just, replace the resources. The meme like, you made this, now I made this, just replace the branding. That sort of thing. Also, the environment. If I have root or jailbreak access to my phone, escalated privileges, it allows me to do even more introspection in the binary. FreeDie is a kind of hooking tool that allows me to also look at the binary or the application, modify it, and so on and so forth. Game Guardian is an example for cheating. If I want to modify random memory locations, increase my number of health points or something, Game Guardian is an out-of-process tool that will scan the memory and just replace those kind of values. So what do? We protect all of them. If I say everything is fair game, then we also have to protect all of it, because in the end, it's as you remember in one of the previous slides, this kind of circular mechanism. If we protect only one thing, then the attacker will use the other thing to achieve the same. So we verify everything. We do a kind of integrity check on the libraries that are loaded, on the code section, on the signature, on the resources. We make sure that we detect when FreeDie is used. We make sure that we detect when hooking or when jailbreaking or rooting is being used. We detect it when memory is being tampered with. All of this we detect, and that's why we need all of that base knowledge about how the systems work, how Android works, how Apple works, or iOS works, that sort of thing. So that's obfuscation. I hope it was a very brief introduction into what we do. And if you have questions, of course, at the end, I'm happy to answer them. Now I want to talk a little bit about the security testing. So AppSweep at the moment is mainly for Android. But in the future, of course, we will also support iOS, and the technologies will be pretty much the same. So very briefly, high level, what does AppSweep do? So it's an automated scanning tool. And again, we focus on the developer perspective. So for us, it's very important that you're able to integrate this in your build process, in your CI process, really from the developer's point of view, and that we want to focus on the true positives, on actionable, usable analysis results that you can integrate into your app or act on in your application. It's also free to use at the moment, so you can go to the URL appsweep.guardsquare.com and upload one of your APKs maybe to have a look at how it works in action. So conceptually, code analysis, it's not. I think it's not that difficult. I think you can all understand what it means to some extent, so I don't have too many details on this. For us, what we focus on is this very intuitive UI to drill down on the issues, to really have some insights and be able to understand, like, okay, what does it mean, what's going on, and be able to focus on what's important, what is really a threat to your application. And then basically, as I said, conceptually it's not that difficult, but there is a lot of analyses, a lot of technology that goes on underneath, of course. The more things we can detect in order of importance, of course, the more value we can add. So we have a lot of different kind of analyses, and all of them have their in the website. It all seems the same, of course, but underneath there is all kinds of different algorithms, background information, knowledge that you need to have about data flow analysis, maybe about slicing binaries, that sort of thing. Lots of things that go on underneath, under the hood. So if that's your thing, then we definitely have something for you as well. So as I mentioned, I mentioned ProGuard Core at the beginning, so I want to quickly talk about that because AppSweep is completely built on top of ProGuard Core. So remember, we started with ProGuard, DexGuard was built on top of that, and now AppSweep is built on top of that. That's because ProGuard was actually, it contained many similarities with LLVM in the sense that it's basically a framework, a compiler framework that you can use to read, analyze, modify Java bytecode with. So in the same way that LLVM can be used for LLVM bitcode for the languages that they support, ProGuard Core offers similar functionality for JVM languages, so also Kotlin. And so if you're ever interested in doing that sort of thing, doing compiler related projects on JVM code, then definitely go have a look at ProGuard Core. You can do a whole lot of things with it. It's very well built. Eric was is a very good software engineer, and so it's if nothing else, I think it's just an interesting project to look at. So then we get to working at Guardsquare. So I put this slide on here because I think it shows very well what we're all about. This is a picture taken in Lisbon last year. So we went to Lisbon with the company because basically what we do is we set the bar high, we set ourselves goals, we achieve them usually, and then we celebrate. That's a very nice summary of Guardsquare, I think. And it's important to emphasize that really most of us or all of us really like working at Guardsquare and really have the goal in mind of building something nice. R&D, for example, the team is 40 people. In my opinion, we're still a group of nerds together who just like to work on compilers, reverse engineering, obfuscation, security, code analysis, that sort of thing. And so when we set goals, when we aim high, we usually achieve them. And at Guardsquare, for us, it's very important that there's a right balance between work, life, and well, working hard, and then also celebrating when we achieve what we achieve. So yeah, this is a good example. Of course, we don't go on a trip every month. We went to Rome a few years before this, and then there was COVID. So I don't know when the next time will be. But there's also lots of other things that we do. There's always, if there's, as I said, if there's something to celebrate, we celebrate. There's always some champagne in the kitchen or some beers. But there's also nice team buildings, barbecues, nice dinners with Christmas, that sort of thing. That's the fun part of working at Guardsquare, and that's the important part for us, the cultural aspect. So I mentioned offices. So for developers, Leuven and Munich will be the most interesting. Leuven is still the main headquarters, but also the big part of the development team is still there. And then Munich is where AppSweep is developed, and a part of my team, the LLVM team, is also in Munich. They were laughing at me when I put the area and the population on the slide. The reason is that I just want to give you a sense of perspective. I think most of you will have a picture in mind of Munich. It's a very big city in Germany, of course, almost 1.5 million people. It's apparently a fun city to live in. That's what the articles say, and that's also what, of course, the team in Munich says. But Leuven will be maybe less familiar to you guys. So that's why I want to show you it's 6 times smaller than Munich. So it's a fairly small town. But it's still a city, so there's still plenty of things to do. And it's also a university city, an international city. So if you're from abroad, it should be very easy to integrate and to get around, because everyone there is either also from abroad or they just speak English very well. And then when I was making the slide, I asked the Munich team, like, hey, what should I put on there for Munich? Well, apparently it's sausages and pastries. they first said beers, but I was like, no, 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 no. And those go on the Leuven side. So if you're interested in beers, there's the Automatic, apparently the longest bar in Europe. I've been told multiple times. So definitely a good place to explore the Belgian beer culture. And so that's it about yeah, working at Guardsquare from a people perspective. What it is that we're looking for is mainly solid software engineers. All these things I've talked about, reverse engineering, compiler, security, all of it is extremely fun, of course, and interesting. But what it in the end boils down to is that we build a complex piece of software and a big piece of software. So what we're mainly looking for is solid software engineers who like to think in terms of algorithms, who really like to think about code architecture, clean code, all of the good coding principles. Maybe you're very interested in programming languages in general. That's the sort of profile that is very that will fit very well in our R&D culture environment. And in the end, it's very important that you're motivated to learn, because I know very well that compiler engineers, they don't grow on trees. Maybe some of you who are listening to this, you're like, yeah, I know all of this LLVM, reverse engineering, I'm a C++ wizard. But for some of you, it might seem a little bit more daunting, which is fine. If you have the right motivation and you have the right background, I am 100% convinced you can catch up. And of course, it's nice to have some background in some of these topics, but it's not strictly necessary. So yeah, on the right-hand side, you see some of the positions that we're hiring. So in my team, the C++, LLVM obfuscation team, the app analysis team, but also in James's team for Java, TextGuard. Those positions are all available. And then also, as you've seen some screenshots from some web UIs, we are also looking for full stack engineers to continue building on these front ends. And if you're interested in DevOps, that's also a position we're still trying to fill, well, or to extend, which I should say. That's my part. So I want to give James the opportunity to give his perspective on things. Maybe he's going to contradict everything, but I hope not.
So I just want to basically explain how I ended up at Guardsquare. So a bit of background there. As we already said, that I worked at CERN for 3 years, but the story about how I ended up at Guardsquare kind of started before that. So I did a master's degree and a PhD in London, mostly around code analysis, and started the preliminary research for that was about decompilation, obfuscation, watermarking, around some of these kind of security issues. And that's actually where I first heard about ProGuard. So I heard about ProGuard many years ago, before I heard of Guardsquare. And I'd used ProGuard in one of the experiments and one of the papers that I wrote there as part of the preliminary research. That kind of morphed a bit in the year or so that I was doing this preliminary research. So the final PhD was related to program slicing, dependency clusters, dependency communities, and software metrics. So this was all about analyzing code and representing it as a graph and looking for patterns in that graph. So this was useful for example, for program understanding how program works, decomposing it automatically into different components, and for metrics about the program. Is it well written? These things like cohesion coupling, these kind of metrics. So that's before I was at CERN, and I was very interested in these kind of compiler technologies, code analysis. And then I got a job at CERN. I was working on some completely different stuff. It was also very interesting. So this was I was in the Beams department as a research fellow, working on control systems. So I mostly worked on the WinCCRA framework. One of the big projects there was SCADA statistics monitoring service, which was using the data from the WinCCUA control systems, putting that data into Elasticsearch and analyzing that data and getting some useful information from that. So this was something that I presented at the Eclipse conference in 2017 while at CERN. And then the other thing that I worked on at CERN was CETAMON, which is another control monitoring platform at CERN. This is Java-based development. So I spent probably about maybe half of my time at CERN working on this Java-based control monitoring system. And then after CERN, I was there as a research fellow for a 3-year contract. So after that finished, I decided to go traveling for a bit. That gave me some more time of thinking about what I wanted to do next. And so then while I was traveling, I started looking for a job, and I decided that I wanted to do something again that was more related to the PhD, which was code analysis, compilers, these kind of topics. So I was looking for a job in that area. One of the things that popped up was Guardsquare. I was looking mainly for, with a higher priority on the job than the location. So I applied in a few different locations. And then, yeah, Guardsquare was one that popped up. I'd never heard of Guardsquare, but I did hear of ProGuard before. So that's why I got a bit more interested in that application. So now I'm working on the Android team at Guardsquare. I've been here for 3 years now. I live in Leuven, as Android already Andre pointed out a few nice things about Leuven. It's a small city, but it's a nice city. And I work on DexGuard, ProGuard Core, ProGuard Playground, Kotlin metadata printer. So there's quite a few different things to work on, but it's all based around, it's all mainly Java, Kotlin. ProGuard Core is all about manipulating the Java bytecode, but we also have to work with the Dalvik bytecode because Android uses Dalvik, not Java. So we also have conversion software to convert between the two. Yeah, if you're interested in getting the flavor of the kind of code that we write in Android team, you can look at ProGuard Core, ProGuard. These are open source projects. And the Kotlin metadata printer is also open source project.
Thank you both very much. Thank you for a very interesting presentation. Thank you for walking us through the history of the company and as well your product challenges and solutions that you have in place. And it was, of course, very interesting to hear from James as someone coming from CERN, talking about how you find your way to Guardsquare. I think one thing that we didn't talk about yet is the recruitment process. So maybe if you could let us know, how long does it usually take? How many rounds there are? If there are any tests or assessment centers? Yeah, that would be very interesting to know, I think, for our alumni.
Yes, so it's a good question. So there is, we try to keep the process as short as possible, of course. So it's very important for us that we have a low turnaround time, as I say. So usually we aim at 2 to 3 weeks. We really try to aim at 2 weeks, but depending on calendars, it can take a little bit longer, of course. So on the first application, you will be contacted by maybe Marjorie, who's in the call, to just have a quick chat like, hey, what it is that you're looking for, just try to get a better feel. And well, usually give a bit of the explanation that that I gave in this presentation, essentially. So maybe this time we can skip a part of that. After that, they would, or there would be an interview scheduled with the group lead. So that would be me or one of the other group leads to do a kind of, we call it a cultural interview. So basically it's you getting to know me and me getting to know you, trying to see if there's a match and really just learn more about each other. If at the end of that conversation we like each other, then there would be a next technical interview where we ask some questions about the programming language that will be relevant, solve some questions about the language, and implement an algorithm at the end. Usually people don't have to prepare that much for this, and it takes like an hour and a half, depending on on how well it goes, essentially. And then there would be a final step after that technical interview with the CEO. So for this, I mentioned a few times the company culture and how it's important for us. When we say that, we really mean it, because the CEO also wants to just make sure that you fit in the company, that you would be a good part of it. You don't have to be scared of him. It's just he wants to get to know you as well. And that would be then, if then everything is well, the offer, the official offer, of course.
How long does it usually take? Because I think people here in the region, they are used that in Switzerland, sometimes it can take between 3 to 6 months until we get the final result.
So as I said, the first cultural interview, and then I try to do the technical interview in the same week even, or the week after. And then the CEO interview also, that after the technical interview again, same week or the week after. So if worst case, it's about 3 weeks, but we try to stick to 2.
I have one question in my private chat, whether you recruit non-EU people, or like, well, you have offices in Canada and US, so I guess there, yes, but let's say in Europe, do you sponsor visa requests?
Yes, we do. So as I mentioned I didn't mention it maybe, but we're an international company in that sense, and we recruit internationally as well. And for us, it's just about finding the right people. And then if it's a non-EU person, then yes, we will sponsor the visa. But of course, the match needs to be there in the first place.
Yeah. All right, and I see another question in the chat.
Indeed, 3 technical questions. The first one, like if we take a banking app as an example, and you know that most of the things would happen on the backend anyway, and like the bank would need to protect its backend. Also because you can't hide API too much because it's still accessible through online client, through web. So what would be the benefits of the portfolio of products you suggest to the developers inside the bank on top of this?
Yeah, so that's a good question. For APIs, it's a little bit tricky. So first, the fact that an API is used in multiple places doesn't matter that much, because that should be protected in every place that you use it. But there are many use cases. For example, with APIs, this is a complicated question, but first of all, you can hide the usage of the API as much as possible. I know you're thinking about other applications that are also using the same API, but still, it helps to have them protected or hidden, at least in the app as well. Then there is also the usage of the API. It's not because the API endpoint is available that you automatically know how to use it. And in fact, often using the API or abusing the API is significantly easier from the app. So instead of me trying to understand how this entire API works, I can just call the function in the app using LLDB or Frida that uses this API and just have the message crafted for me. That's that's not insignificant, because if I have to craft this message from scratch entirely, make sure all the parameters are in the right place, make sure it's signed, encrypted, whatever, if I can just tell the app like, hey, set this for me, that's significantly easier. That's one thing about the APIs, of course. Another use case for banks is fake applications. So if I put an application in the wild, someone else might just strip it, put other data in it, maybe another logo, or keep the logo in this case, and have the data sent somewhere else. And that's a very real threat and problem that they have, because often that's why they come to us. They see that customers or their customers are being fraudulently sent to different applications. They complain to the bank, of course, and that's when they end up at our doorstep.
Oh yeah, faking up is indeed a scenario. I did think about it first. Thank you.
Yeah.
My another question is about the code obfuscation. Correct me if it's wrong, but at least before this might render the app submission process much more difficult. Like App Store might have rejected the app which has obfuscated code. Is it addressed anyhow now? Do you have any specific status by App Store or Google Play to prevent this?
So we don't. So we are familiar with this, and it has happened. We have to be honest that our customers, their apps weren't able to be sent. But usually, when they then contact Apple and Google, both companies, they appreciate the use case and they understand why it's needed, especially if they explain like, hey, we're a bank, we need this kind of protection, then it's never been an issue.
Okay, but do you have any particular status by like certified iOS developer or something?
For iOS, we don't. I don't know for Android, James.
I don't know if it exists, honestly, but
Yeah.
No, I don't think there's anything official.
Yeah, I also don't think it exists as far as I know. So.
okay. And the very last question is, how do you fit your development process or development cycle within iOS or Android release cycle? Because I imagine you would need quite intensive work to support latest release of the operation system. And what do you do in the rest of the year?
Yeah. So you're right. It's good. It's a funny question because integrating with the newest iOS and Xcode and Android and Gradle is not the fun part of the job. I have to be honest there. So the rest of the year we do the fun part. We do the protection mechanisms. We investigate new technology, like Unity, for example, is something we support that we've been working on the last couple of years. Supporting Flutter, there's always new things to do, new techniques to investigate. So that's what we try to spend most of our time on. But then, yes, we are familiar with the release schedules. We know, of course, in the summer, new Xcode, new iOS version will be released. Also in winter, there's usually a new Xcode version, similar with Android and AGP and all these things. We're aware of when they more or less will be updated, and we plan time in for this, and then we just deal with the consequences.
Then I ask another more recruitment related question, which is a question that comes up a lot lately, and it is about the possibility of remote work. One question, and another is whether if somebody doesn't find a specific job position they would like to apply for on your webpage, if it's possible that they send a spontaneous application.
Yeah, definitely spontaneous application is always welcome. If you feel like you would be a fit in some way, always welcome to reach out. Work from home policy is, okay, so I mentioned that my team is split between Leuven and Munich, and I'm going to give you a short summary of how that happened. So I needed more people in my team, and so the logical answer is you hire in more locations. Good. What we don't want to do, or what we didn't want to do, is have people all over the world working completely remotely from their home office and that sort of thing, because as I mentioned a few times, for us that cohesion is very important. I think it's very important that you know your colleague, that you know the person that is reviewing your code, that is virtually or physically sitting next to you, and that you can then also have this social connection with them. And so for that reason, we don't do full-time remote. Our policy is that you have to be in the office at least 2 days per week. And so we can be quite flexible with the other 3 days. The other 3 days you can be at home, like I and James am at the moment.
Perfect, thank you. And I see that Marjorie put her email address in the chat, so you can contact her in case you have any more questions or you want to send a spontaneous application. And now Radmila has a question.
And just one comment, what a nice presentation of the culture of the organization. So hands up on that one, because one really have a want to work for Guardsquare. So it is not Guardsquare. Sorry, it is not that often you get that side of the company. So it was really nice to see that. So thank you.
Thanks, it's a nice compliment.
And we are nearing the end of our event. So thank you very much, all of you, and we see you in the next event.